of integrity. Okay. There's a saying in the East that says, everybody pay attention, that when wealth is lost, especially in the US, we relate to this. When wealth is lost, nothing is lost. Why people lose fortunes, they make fortunes, build their fortunes. So when wealth is lost, nothing is lost. When health is lost, something is lost. So those of you with weak constitutions, I think I do too. I'm prone to respiratory disorders, because of sinusitis, chronic. I have a deviated septum, so I'm prone to chronic sinusitis. So when health is lost, something is lost. The most important thing, I'm sure your parents have told you this, especially your moms, that when character is lost, everything is lost. You cannot. Just imagine somebody gets accused. Think about it. This is happening right now. Those of you watching the news, reading the newspapers. If somebody gets accused of sexual harassment, we think of him forever, as a creepy guy. Now they did a study. They did a poll of women, and they said, which abuse do you reserve to the worst guys in your life? And then they polled the men. They said, which is the worst abuse you think you're being called by a woman? The two abuses for men, as in they feel really profoundly hurt and offended when they are called these two words. One is asshole. It's a very simple thing, but that's like profoundly disgusting and offensive. The second thing was creep. If a guy is called a creep, it is one of the most, it's like, women are not safe around me. That's basically the definition of creep. So, I'm coming back to the idea when character is lost, everything is lost. You cannot live it up. Okay? If someone sees you in a supermarket stealing something, you have a good reputation. You take a necklace, because teenagers, that's the years you kind of take risks. You go to the mall, you take a small handbag or wallet or this thing. Somebody who has a high opinion of you, your neighbor, your uncle or whoever, sees you, in your mind you're a thief. In their mind you're a thief forever. You can say, I'm so sorry I've cleaned up my act. Your uncle will always think of you as a thief. It really is a fact. So once again, when character's lost, everything's lost. Why do I say this? Because last year, I found a couple of kids cheating. So I gave definitions of cheating. One, getting help, looking at your notes, so Googling for the answer, asking an alumnus from last year, or alumni, multiple people, all right? Or not grading accurately, just giving yourself points, just making up a value. I never trusted those kids for the rest of the year. I never did. Anything they would turn in, I will look at them. I never trusted it. Some kids I'll say, no, I don't even care. I'll say, yeah. So I gave her the key and I said, grade your own test, I don't care. Okay. So the English word is unimpeachable integrity. Because when you have positive character, that stays in my mind. But you do one mistake, okay, you're a creep. I'm going to monitor every single thing you do. And one of these kids came to me for a recommendation, I turned them down. His character's lost everything they lost. So especially kids at the lower end, the temptation will be strong. You did poorly on that one test, the temptation is very strong. Let me just massage my grades. But it'll be small. Like, let me give myself 1 point, 2 points. It starts small, right? Usually when dishonesty starts very small. You'll say, I'll just give myself another point here. And the next test, I give a take-home test. Okay, I wasn't found when I increased my score by 1 point, but I did 3 points. And that's where it begins, see? You will be caught. You will be caught, all right? I've been doing this for 15 years, so I pretend to be a very bright guy. Okay, and then once again, in my mind, you're a liar and you're a thief. And I will never forgive that. I'll never forgive you. And here's the thing, please understand, teachers talk. Will Belo found out? Absolutely. Me and her talk all the time. When you go to her, go to recommendation from her, see if you get it. It's not worth it. A couple of points, not worth it. Okay. So my joke to period 2 is this, and you'll get a chuckle out of it. Okay, this is the bubbly thing of the day, Miss. So this is the joke I told in period 2. Please understand, your grades are not going to rise dramatically if you give yourself a couple of points here or there. They're not going to rise. I hope you understand the grading book. So if you want to cheat, be ambitious. Is that a fair gag? So if you really want to cheat, but here's the downside, you'll be caught. So it's like, I think the English expression is really a devil in a hard place, or rock. All right. So if you really want to affect your scores, you should be ambitious. But in statistics, we call it a chi-square distribution. I have your expected frequency in my mind. Okay, throughout the year, this kid got these scores. And then observed frequency, like, whoa, what did you get? How did that happen? I will investigate. Of course, I'm looking at all the papers, but I'm just telling you. So it's a challenge. For those of you who are given to dishonesty, I know it's a challenge. I'm sorry, I can feel for you. I feel for you. All right. We're doing, today, we're going over some of the questions. Mr. Nava brought these to my attention. So we're going over them because one of these is going to be your final. All right. Have a look at this question, please. We will do increasing, decreasing, concave up, concave down. All right. You don't need to sketch. Just write on day 78.
Yeah.
Okay.
Is that another Target shirt?
It is the same target shirt. It is exactly the same target shirt. Huh?
Didn't you buy 10 of them?
Yeah, I bought 10 of them, but they were multiple colors. They're not all the same color. So I have a green, I have a red, and I have this. But they were, I don't know if I mentioned this yesterday, so they were like small, medium, large. I just bought everything. That was it. They were on clearance. I paid, for those of you wondering, $7.98 for these.
All of them or
Just
each?
$7.98.
Each or total?
All right, anyway, moving on. So I just want to discuss concave up and concave down. Okay, focus. We'll focus on concave up and concave down. Stay with me, please. So concave up. This is the f dash function. Okay. For concave up, should the slopes be increasing?
They should.
Okay, the slope. And remember, these are slopes. So I taught this lesson at UCLA this weekend. So these are the slopes. So the slope's increasing. Okay. So from -6 to -4. And keep in mind the slopes should exist. Okay, the slopes are increasing. Or in other words, the slopes exist at each point. For this graph, okay, the slopes exist. And then the slopes are decreasing here, so from -4 to -2. Okay, then the slopes are increasing. Yes? So -2 to 0. Then the slopes are decreasing. So here's the question Ms. Nava brought to my attention. So should we write 0 to 3 or 0 to 2, 2 to 3? That's the question that students have when I'm clarifying the concept. Thank you. We need a break. We need to do 0 to 2 and then 2 to 3. Because can you see, at that point, the slope does not exist. The slopes are decreasing. Can you see, the slopes exist, slope exists, slope exists. And the slopes are decreasing. We have a negative slope. But at here, can you see, I don't have a positive slope or negative slope. So you have to break the graph. So it's 0 to 2, 2 to 3. Okay, I want to clarify that concept. Okay. Now, let's do increasing interval. We'll do only increasing interval because it's important. Okay, here's my question to the class. Increasing interval, keep in mind these are slopes, that's the f dash function. Should I go -6 to -4, -4 to -2? Or should I go -6 to -2? Nobody speaks. I'm giving you thinking time. Once again, there's a challenge. In getting it wrong, you lose your points. Keep in mind the definition is f dash greater than 0. So my question to the class is, should we break the interval, don't break the interval? Chorus? Thank you. Because at -4, are the slopes positive? Remember, these are slopes. Yeah, the slope is fine. The slope is fine. Therefore, directly -6 to -2. Exactly. I want to clarify that concept. So ponder, pause for a second saying, what's 2? F dash be greater than 0? Oh, yeah, it is greater than 0. There's no reason to break. But its slope does not exist. So I'm going to write a couple of things. Look at the board. Convince yourself why both are true. Repeat. Both are true. Yes? 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 Okay. Because we have a sharp corner. Its slope does not exist. Alright. I want to make sure there's no confusion on that issue. Because there are 2 of those on your final. Okay, we'll discuss these. Yeah. Okay, this one, there's one on your final. This is your 3rd time you're looking at it, if you care about how many times. Okay. It says, consider the function g of x as defined below. So this is g. Okay. How cute, Ms. Rising is actually sketching the graph. Okay. This is g of x. And the question will say arrange. Write this down if you need, if you want to. But I'm copying I'm writing the question. Arrange g of 1, g dash of 1, and g double dash of 1 in increasing order. In increasing order. Oh, sorry. No. Stop. We'll make it 2. I just did math in my head. It won't work. 2, 2, 2. G of 2, G dash of 2, and G double dash of 2 increase here. Now we're good. So keep in mind in all these questions, you're not doing any math. It's just a concept question. Just look at signs and values, all right? Yeah.
Are we considering G of 2, 1?
It doesn't, it's not even relevant to the problem. Okay. What do we know of G of 2? It's positive. Okay. I understand your point, now it won't even affect your answer. What do you know about G dash of 2? Zero. It's a horizontal tangent. And what do we know of G double dash of 2? It's concave down. Yeah? You don't have to think too hard. It's obviously concave down. This is the original function. So it's less than 0. Okay? Understand that. Now, so your answer on the exam will be this: G double dash of 2, G dash of 2, and G of 2. Okay, that's how you frame the answer. Is that clear? Let's do another question. Same concept. You'll see two of these, but this one involving integrals. Write this down. So, new question. Just draw a line or write down an example. Now, I say it's an integral question. G of x equals 0 to x f of x, where f is that function. Relax, I'll scroll. Again, it's 0 to x f of x. So this is f, and G says 0 to x f. The question says compare. Was it 1? Yeah, compare G of 1, G dash of 1, G double dash of 1. Okay. So what do we know of G of 1? Is it 0? No, slow down, think about the problem. It's negative because it's 0 to 1 f. This is obviously less than 0. Alright? We need G dash of 1. So what should we first find? G dash of x, which is this f of x, ftc2. Therefore, G dash of 1 is f of 1, which is 0. It helps to show work. And finally, we need G double dash of 1. So what should we find first? So is that G double dash of x, which is f dash of x. Therefore, G double dash of 1 is f dash of 1, which is positive. Actually, do the line up exactly in that same order. Okay. So G of 1 less than G dash of 1 less than G double dash of 1. Okay. We've done lots of these, but I pretend to be a good teacher, so emphasizing certain concepts. Okay, we'll do a bunch of limit problems. Each of these may be 1 minute. Oh, can you hit backspace when I tell you to, please? Hit backspace. And then hit backspace.
Thank you.
Okay, hit enter.
Control Z.
Okay, thank you. Very good. Backspace. Okay, guys, we'll do that problem. Just write an example. What do we always do first step for limit problem? Test it. No, not test it, as in just plug it in, right? H is approaching 0. What's ln of e?
1.
-1,
1 to 0.
0, and 2 times 0. So should we apply L'Hopital's rule?
Okay.
So what am I writing? Limit h approaching 0 over e plus h over 2. And h is approaching 0. So what's your final answer really? Look down. Is it 1 over 2e? Backspace, please. Okay, next problem. Copy that down. You have one of these. Okay, careful. The only reason I'm doing this class, not because it's difficult, but you'll make an algebra mistake. I want to point that out. Okay. Let's plug in 0, which is that 1/2 cube, which is 1/8. Minus 1/8, 0 over 0. Okay. Now careful, I'm going to apply L'Hopital's rule. H approaching 0. Okay, tell me what to write. Careful. 3 1/2 minus h squared times -1. That's why these guys are saying -3. I want to show that step. Okay. Over 1. Okay, tell me your final answer. You now apply the limit. Tell me your final answer. Slow down, slow down. Equals negative 3/4. Okay, careful. Okay. No, what document is this? Yeah, another point. Okay. Write an example. We're doing this one. We're doing this one. I'm just doing it for algebra, making sure even the lower kids are okay with algebra. Equals limit thank you, e to the power of 1 minus h times negative 1. For those of you who've forgotten, h is the variable. Keep in mind h is the variable. Over 4, final answer. Okay, careful. Negative e over 4. Okay, it's algebra. Okay, we'll skip the next one. We'll do this guy. Okay, copy this down. We'll do the next two. Relax. I'll move on. Yeah, we'll do the next two. So as before, h is approaching 0. So e3x minus e3x is 0, 0. So limit h approaching 0. Careful. I want to emphasize this. Which is the variable? H. X is not the variable. X is the constant. Okay. Keep in mind, h is the variable. Okay. So e to the power of 3x minus 3h times negative 3, because h is the variable, minus 0 because x is a constant, over 4. So final answer, negative 3e to the power of 3x over 4. Okay, I want to emphasize that. Okay, we'll do the next one. Okay, so if you plug in 0, you get sine 2x minus sine 2. Okay, tell me what to write next. Louder? Okay, 2 cos 2h plus 2x minus 0 over 1. Where's Nama? No, the now that matters. What's your final answer? 2 cos 2x. Okay, h is the variable. Don't forget to take the limit. Don't forget to take the limit in the last step. We'll skip this one, we'll skip that one. Okay, we'll do this one. We're doing this one. Okay, once again, I want to emphasize something. Which is the variable? How do you know? Okay, look at the left hand. Thank you. X approaching. The left hand guy is always the variable. Keep that in mind. Okay. If x is approaching c, can you see that's 3c plus 1, basically 0 is 0. Okay. So tell me what to write. We're taking log algebra. X is the variable. Tell me what to write. 12 plus 1 to the power of 3 times 1. Yeah. Minus 0 because c is a constant over 2x. Okay. Final answer? Can we write 6? C plus 1 q over c. That's it. It looks weird, but that's okay. That's okay. That's your answer. Let's do that one. The top one. We're doing the top one.
So after we use log Hopper-Tot's rule,
Apply the limit. Just apply the limit. And make sure you still don't have 0,
this is
0.
just plugging in C, right?
Yeah.
Or whatever.
Yes, x approaching c. Okay. Sine of 0 minus 0. E to the power of 0. So do we get 0 to 0? Okay, careful. All right, tell me what to write. Careful. Limit h approaching 0. 12 cos 3x minus over, careful. Do you understand why it's positive 2? Because negative x. Okay, 2 e to the power of negative x. Okay, tell me your final answer. Tell me your absolute final answer. Is it 6? Okay. This collapses, cos 0 is 1, E 0 is 1. So 6. Okay. We'll discuss this problem. This one. The top one. Who remembers? So we have sine 2 times 0, 0, sine of 0, 0. Who can tell me how to do the problem?
Rewrite it.
Give me more.
Sine of 5x times
Thank you. We split it up. So the 2x and 3 just come outside. They're not relevant to the problem. So it's 1 over sine 5x, split up the trig, and then balance. We have a 5x here, we have a 5x. So what do I balance here? 25x squared. Is that clear? What does this become when I take the limit? Okay, apply the limit very carefully, simplify. Apply the limit very carefully, tell me your absolute final answer. Those two collapse to 1. But now do the algebra. So what is your absolute final answer? Does not exist, thank you. If you do it correctly, you get 2x over, say, 75x squared. But you have to take the limit, and 2 divided by 0 does not exist. Okay. Mr. Sanwan asked me this question. Guys, Sanwan has I like to say, like, relentless pursuit of perfection. Sanwan wants to know how to do every single problem. There's one thing on the homework, so does Mr. Tan. There's one problem on the homework, it troubles them, they'll come during the morning, or Mr. Sanwan usually stops by during lunch. So, this, have a look. It says, find the intervals over which that function is increasing and decreasing, then identify the relative extrema. So, how might I do the problem? Here's the problem with this problem. If I say extrema, I just say relative extrema. How do we always do any algebra problem relative extrema? Look here, don't look at the problem. I give you a function f of x and I say find the relative maximum. How would we do it? Let me tell you the wrong way to do the problem. Let me tell you the wrong way. Tell me why I'm wrong. What am I getting confused about? So my answer is critical points, endpoints. That's absolute extrema. It has nothing to relative. Relative, as Mr. Bourbonnais says, usually we do number line. Is that clear? That's how we do relative extrema. I'll say where f dash changes signs. Is that clear? Thank you. So Mr. Nava points out, I have an ln. I can't use number lines for that problem. So he then points out we'll use a double derivative test. So I'm exposing you to that effect. Okay, so it's first find f dash of x. So we go over it. Quotient rule. Denominator.
X squared
Top left.
x
Times
1 over x.
minus ln x times. Okay, let's clean it out. Guys, rewriting is your friend. Look down. What does it really become?
1 minus
ln x over
x squared.
x squared. Okay. We cannot use a number. You can't just magically put a number line at plus minus. Like what? What in algebra, do you know anything about that function? Do you know how it behaves? You can't. So it is smarter to basically use the double derivative test. But the double derivative test is first find the critical point. So we'll set it equal to 0. Okay, find the critical point yourselves. In simple language, just set the top equal to 0. The domain is x greater than 0, so just set the top equal to 0. So x equals e. So for those of you lost, 1 equals ln x, or ln x equals 1. Therefore, x
Now,
equals
if you set the top equal to 0, isn't that the same as finding a root?
Yeah, we are
If you're
finding
finding a
a
root, then why couldn't you use a number line?
No. But the concept, the idea of a number line is, or the number line works for algebraic functions, for polynomial functions. It does not work for what I call in upper level math. Okay, I love this guy. Transcendental functions. It does not work for sine, cos, tan, ln, e, sine inverse, cos inverse. Number line just don't work. Okay. So anyway, so next I will find the double derivative. Again, quotient rule. Bottom, top left, times derivative 1. Smart to write the 0, minus 1 over x, minus parentheses 1 minus ln x, yes, times 2x. Okay, rewriting is your friend. Rewriting is your friend. So what is the first expression really? Negative x minus, and put that 2x in front so it's easier to look at. 2x parentheses 1 by ln x. All over x4. You could do this, but you need not. Guys, you could do this if you want, but you need not. We're ready to plug it in. So the double derivative test says, find the critical point, plug it in the double derivative, the answer will just magically show up. I'll show you why. So we do f double dash of e. So it's negative e minus 2e parentheses 1 minus ln e. Okay, let me tell you a common mistake at this stage that students make. Tell me the mistake I'm making. I'm speaking over the board. Negative e minus 2e, negative 3e. Pem dash, please. Common error, common error. Okay, over e to the power of 4. So it's negative e. Ooh, what's ln of e? So what is the expression really on top?
Negative.
Over e to the power of 4. I don't even need to cancel it. I can simplify this, but I don't. And that is obviously a negative number. Okay.
Oh yeah.
So that's less than 0. So let's see what's going on. If f double dash is less than 0, what must be true on the graph? Hint, it's f double dash is less than 0. It's concave down. Make a small sketch so you know what's going on. Therefore, it should be a relative max. So the answer just shows up. So make a note, therefore we have a relative max. Why is that useful? Oh, watch. I can now go back and make the number line. So f dash. So what should I write here? Now can I answer increasing, decreasing? I'll make a mistake. See if you're bright and tell me the mistake. Increasing interval negative infinity to e, decreasing interval e to infinity.
Can have negative.
Thank you. We have an Ellen. She's smart. She says the domain is x greater than 0. So write down domain. Increasing interval is e. Negative 0 to e, decreasing interval e to infinity. Okay, that's increasing interval 0 to e. Look at the domain. Okay. So when do we use the second derivative test? When the first breaks down as in. We cannot use number lines. Can you enter like 5 times or 4 times? Thank you. You have one question like this. Someone tell me how to do it.
Oh, x-intercepts.
Thank you. Very smart. So we'll first, it's an absolute value function. I need to make the area below the axis positive, like compel it to be positive. So I don't need to graph it. I can just find the x-intercept. So x squared minus 2x equal to 0. Therefore x equals 0 and 2. Keep that in mind. We'll break down the integral. Okay, guys, observe this, and observe this. Okay, tell me what to write.
Negative 2
2,
to 0.
0.
Absolute value after that. Or
Outside absolute value, yes?
oh yeah.
X squared minus 2x, not inside. Because I'm making the area positive.
Right.
Plus
0 to 1.
absolute value.
Oh yeah.
0 to 1, x squared minus 2x.
Absolute value. That's it.
Those are okay. I'll be honest, I have to change the question on the final. I'll be honest, a BH last year, I made them do 3 integrals. And after a very small fraction got it right because the algebra was brutal. And then I realized but why do I have to do that again? Like why am I killing these kids with 3 integrals? 2 will tell me if they understand how to break up the integral. So I just made a mental note. I have to go this weekend and change that integral problem. 6 integrals. It's like a polynomial with multiple roots.
God,
I hate these kids. All right. Who is raising their hand? Yeah, go.
Are we not going to make 1 or 2?
Sorry?
It's 0.
Oh, okay. Here, guys. He asked a question. Should we not break it 2? Why is that not relevant?
It's only 1.
Okay, you don't have to go up to 2 at all. That's why I made up a easier problem. All right. So x cubed over 3 minus
x squared.
minus x squared. Lower limit negative 2, upper limit 0. So I made an easy one where 0 is part of the question also.
Absolutely.
Absolute value. We'll do the other one in just a second. I just want to just go down one second. Careful. First answer,
0.
0. Guys, it is smart to write the 0. It is smart to write the 0. I'll show you when I don't write 0, what's the mistake I'm making. Guys, look at the board.
The negative side.
Exactly. What's this? I forget to write the 0 and this is what I do. Okay, that's 0. Negative 2 cubed. Negative 8 thirds minus 4. What is the mistake I just made? I have to flip the sign. There's a 0. Minus. Please, when I have zeros, it's smart to write the 0. Even like 0 minus 0 minus parentheses. Now it's negative 8 thirds. It's going to kill you because you're not attentive to the algebra. Minus positive 4, right? Absolute value. And then plus. Now we do the other guy. That's still x cubed over 3 minus x squared. But 0 to 1? Okay, that's easy. We can simplify that. Plus, I mean, to write this above, right? Is that just 1/3 minus 1? Minus 0. Okay. And then, if you're a smart observer, that's where the absolute value kicks in, right? Because that's smaller than 1. And then opening up the parentheses, would that just become negative 8 thirds minus 4? I distributed the negative. Oh, sorry. Positive 8 thirds, positive 4.
Yeah.
Yes? Positive 8 thirds, positive 4. For those of you who don't get it, I would have got the right answer. This is absolute value. You see that? Because I had done that. I take an absolute value. For those of you not aware of what I did, look at the board, please. Here's what I did. I'm showing you mathematically what I did. I have absolute value negative, but absolute negative is positive. So I just did that. Eventually, 2 negatives made positive, I would have turned out to be right. Okay, but I'd seen the algebra anyway. So is that 20 thirds? And the absolute value plays no role, right? It's a positive number, 20 thirds. And then over there, is that negative 2 thirds? Which will become positive 2 thirds. Final answer, 22 thirds. Okay, algebra. But I'm making sure you only have a 2 integral question, not a 3 integral question. All right, let's do a couple of logistic, a couple of enters, please. Okay, we're doing a couple of questions on logistic functions. Stay with me. So it says, even the question is like virtually identical. It says, is a differential equation of logistic function modeling the population of infected people for a certain disease. Determine that. Nobody speaks. I'm giving you thinking time. So what does the question want? L. Do you understand? You should make that connection. I need the horizontal asymptote, right? You see that? Is the horizontal asymptote L? So they've asked that kind of question in multiple choice. So should we go about finding L? All right. So should we write the formula? So dp over dt equals kp 1 minus just p over L. What do we do next step? Distribute. So it's kp minus kp squared over L. Therefore k equals 5 over 6. And then k over L equals 1500. Therefore L equals okay, do this yourselves. I'm giving you a hint. 6 goes into 1500. Do the division I've taught you. Those of you remember, the quick division. Is it 250?
Yeah.
I just
Yeah,
remember
so
quickly.
1250?
So is it 1250? Okay. So write down the answer. So you see that notation. You say, oh, I get it. P is not 1250. So you understand. You're making the connection. That means as t approaches infinity, that's the horizontal asymptote. Oh, but the horizontal asymptote is L. Okay, that's L. And then the question continues. It says, if P of 0 equals 150, determine how long it will take for the disease to affect 1/3 of the maximum number of infected people. So what do we find first? Okay, and then what else do we need to find? Sorry? B. Do we need to find the model? For those of you who forgotten, P of t. So this is your second peak. L over 1 plus b e to the power negative kt. We have to solve an equation eventually. L was 1250. 1 plus b e to the power of negative, was it 3/4 or 5/6? 5/6. P. And we know P of 0 equals 150. Okay. So is that 1250 over 1 plus B equals 150. So it's 150 parentheses, keep looking down, equals 1250. What's the fast way to do this problem? Just divide by 150. So 1 plus B equals 1250 divided by 150. Okay, well the zeros cancel. 5 goes 25 times. And 5 goes 3 times. Therefore B equals 22/3. All right. So your model, please memorize your formulas. It's 1250. 1 plus 22/3. Whatever that is. We can leave it alone. It's not a big deal. E to the power of negative. The question has a negative in it. 560. But what? Does that answer the question?
No.
So it says 1/3 of the maximum number of infected people, which is 416.66. I just did the math in that. 416.66. All right. Actually, we can be smart. We can keep it as. Do the smart kids realize? I can just leave it as 1250 over 3. I'm okay. It'll work itself out. It really will work itself out. Okay. So for those of you not following the logic, it's 1/3 of the maximum number of people. Maximum number of people is the horizontal asymptote or L. Okay. Next step. Cross multiply. I'll keep the variable on the left hand side. So 1250 divided by 3. Parentheses. 1 plus 22 e to negative 560 equals 22. 1250. Next step. Divide by 1250 over 3 or multiply with the reciprocal. I'm showing you how to do it without touching a calculator. And what do you observe? No, what? What just happened here? 1 second. That's.
Aren't you supposed to multiply? Like,
Yeah, why does
Oh, that's me. Divided. Okay.
no.
Why did you pull the 3 when you cross multiply?
Oh, that's just 120.
Yeah.
That's 1250, and that's 1250 times 3, right?
Yeah.
So we're just dividing by 1250. Yeah.
Excuse me.
And it says 3 then on the right hand side. Next step, thank you. Subtract 1 and then divide by 22. Is that 1 over 11? Is everybody okay with the math? And then let's wrap it up. So T equals, and then the final answer, see if we're okay. ln, 1 over 11, all divided by negative 5/6. So you calculate into that, correct? Yes? Yes?
And we are
Done with that logistic function problem. Okay, I don't have it here. I'm just using be kind. Hit enter several times. Okay, there is one question in your final. There will be 0 surprises. There's one question on the final that says.
Wait, why did you? It should be 22 over 3.
Okay, there's one question that says this. Just write an example. If n of t, it's a logistic function. I'm just making this up. Say 1500 plus 1 plus 49 e to the power of negative 0.1 t. Okay. The question says write the corresponding differential equation. Okay. This question has also appeared as this on the AP exam, and I love how they framed it. How fast is n changing with respect to t? Be smart, interpret that using notation. Using notation, what are they really asking for? dn over dt? Isn't that the differential equation? Are you going to make the linkages? Okay, that's dn over dt. Girls, if you're writing good notes and draw an arrow there, like, hey, that's nothing but a differential equation. Because many kids said, oh my god, what are they asking? dn over dt? No, look at the board, look at the board. And you can have a smile, and the kids misinterpreted the problem completely. And they started finding the derivative of that crazy expression. No, it's nothing but the differential equation. They just wanted the differential, but very cleverly framed. Did everybody grasp that idea? dn over dt is the differential equation. Okay, what is the formula for a differential equation? Equals k n kn, yes? K1. 1 minus n over L. Can we just plug it in?
Yeah.
What's obviously L? 1500. What's K? Okay, this happened on the exam last year. Yes? Wrong, Miss Nguyen. The negative does not belong. It's positive. Okay, slow down. Positive 0.1. Okay, it happened last year. Okay, it's just positive. So can we just plug it in? So dn over dt equals k, which is 0.1. Can I write this 1/10? To be consistent, it's a fraction after all. 1/10, n, or n over 10. 1 minus n, which was 1500 over, no, n is n, I'm an idiot, n is n, over 1500. Is that clear? We could rewrite it the other way. Can we use a fraction trick? So I'm showing you what I'm doing the review of the multiple way. So is that n over 15,000? Thank you. Because look at the board. When you do will the denominator be 1500 times the 10? 15,000. 1500 minus n. Is that clear? That's another way. We did those questions. I'm coming back to the world. Okay.
So what form do they want it in?
I might write in multiple forms. Okay. And the third way, let's do the third way, which is the decimal way, just for practice. We proceed here. Over here, the decimal form. Is that 0.1n? And then 1 minus. Did we use a calculator to figure out what is 1 over 1500?
No.
Actually, do it. What is 1 over 1500?
On those would not let you use it.
But good point. If they do, that'll be a nice number. That'll be 1000 or 1200. Something very easy. So what's 1 over 1500?
0.000667.
0.000
Yeah, 3 zeros.
n. Write that down. 0.000667. Now careful, finally, when I distribute, will the first term be 0.1n?
Yeah.
Careful, what will the second term be?
A decimal.
Another decimal? So minus another 0? Does everybody understand why there will be another 0? 0.1 times that. I hope you understand basic decimals. 1, 2, 3, 4, 6, 6, 7. N squared. And that will be your final answer. Final answer.
I know answer.
You went one extra.
You went one problem extra.
Your mom is like one problem extra. Like what? Where did that come from? Someone has issues. Yeah, exactly. The top one. Yeah. Actually, oh my God! I don't know if I did that here first year, but at last year we used to have so much fun. At any kind of at a drop of a hat, everybody drop your hats at the drop. People are actually dropping hats at the wrong time. It's like a convention. People are wearing hats at the drop of a hat. I would say I would move on to mom jokes. It's like, why don't we do another problem? Why doesn't your mom do another problem? The kids would have so much fun. Okay, can you hit enter, please?
Yeah, and usually Pop-Tarts are last year.
But it got awkward. It got awkward in certain cases when the mom joke actually had, say, sexual connotation, and that becomes very awkward. So, for example, I'm giving you an example. So, why don't we do another problem? Why don't I do your mom? Okay, that went too bad. I didn't mean that, guys. I didn't mean that. I have to be careful what I say. Depends on the context, right? Can become very awkward. All right. Have a look at this problem, please. It's a half-life problem. We've done questions like this before. So it says the half-life of a radioactive substance is 150 years. And if 10% of the original amount in a human bone, carbon-14, no, suppose we carbon-14. Just say if 10% of the amount remains, okay? How old is the substance? Now, if you're copying down the English word problem, I'll give you time. Yes, you're right. So it says the half-life of a radioactive substance is 150 years. If 10% of the original amount remains, how old is the substance? Who remembers what's initially missing that we need to find? R. So Mr. Bowman correctly says is A word. Alright. I don't know if you were aware of it, but I just pointed out, I just did or performed or executed something very rare, which is I used the word Bourbonnais and correct in the same sentence.
Wow.
I said Mr. Bourbonnais is actually correct. It's very unusual, okay? It may not happen very
You
frequently.
like captured this.
Yeah, I
moment.
captured this movement. He is
On
recording
camera.
it, and I've recorded the fact that you.
Wow.
Okay.
Wow. I'm gonna remember this moment for a
Yeah,
long time.
exactly. He's like driving today the wrong way in a one-way street. The cop pulls over. What are you doing? I was right today. I'm exempt. He's like handcuffing Bourbon, and he says, "Check my left pocket." Like, okay, and it says, "Get out of jail free." I was right today. He's actually carrying a Monopoly card. Get out of jail free. Not today, officer. Not today. I was right in the house. Doesn't happen very frequently, and he's showing even videographic evidence. Here's the video of it.
Check my YouTube channel.
No, it would be sad though if the officer actually indulged and he said, "Okay, show me," and at that point the video got corrupted. It's like, and it's like, guys, it doesn't happen very frequently, but Mr. Beep was actually correct. No, that was me. That was me. Can you see? You caught the end. Mr. B A's. That Bourbonnais. That's me. It ends in A's. That's actually me. Like, that's not enough. There could be so many kids whose names end with A's. All right. So, guys, see, this comes back. We'll use an initial piece of information to find R. Okay, the second part is a very different problem. So there's half-life. So what do we write for 18? Half-life. Or can we write 0.5? A0 equals ER2. Now, when I taught recalc, I would emphasize this. Guys, it's smart to write the letter. Oh, and it says 150 years. Is that 150 here? Okay, T is 150. It is smart to write the letter on the left-hand side. So I'll write equals 0.5. I encourage you to do that. The variable you're solving for should be on the left-hand side. Can we cross out the A naughts? So you know, I'm solving for R. So e to the power of 50 R equals 0.5. Next step? ln. So we have 50R equals ln 0.5. Next step? So 1 over 50.
150
Oh, it's 150, sorry, 150. It's part of the T, it got melded with the T here, I can see. So 150 ln 0.5. Okay. And then, so we now know the model, so I'm writing the model. So the model really is AT equals A0 e to the power R, which is 1 over 150 ln 0.5 T. Is that clear? Okay, the calculator can handle that, but I'm just showing you what the model is. Now the question says, if 10% of the original amount remains, how old is the bone? So what are they giving you now? 80 is 0.10 A naught, is that clear? 10% of the original amount equals A0 e to the power of 1 over 150 ln 0.5. How old is the bone? Am I solving for T?
You are.
Yes? Will the A naughts cancel out? And can you guys take care of that? Can exponential form go to log form, blah, blah. All right, I found this morning in a multiple choice. I wanted to share this with you. Okay, read. If you're aiming for a 5, copy down that first sentence. Just write an example. I don't care if you copy the rest of it. You could use notation, but that is important. Okay, we have never discussed a question like this. I said, man, I have to talk to my students about that.
The ones that are on the board.
It says the growth rate of a bacterial population is constant. Does anybody know what that would automatically imply?
X to a.
No. Look at the board, please. Draw an arrow. That's basically the exponential function. What? That's the growth rate, like 5%, 10%. Can you see? It's an exponential model. Oh, that means it's actually a word. wanted you to make that
That's it?
connection. Yeah, that was it. But if the growth rate is constant.
But couldn't constant also mean linear?
No. Linear, oh my god, it comes on the SATs. The key difference between, that means growing by the same amount every year, not by the same percentage. This is growth rate.
Okay.
Guys, he says could not be a linear model. Assume for a
Oh,
second
yeah.
we have P of T equals, I'm just making this up so you can see live. So you have 150 plus 30T. So every year the population grows by 30. Can you see that? Every year it rises by 30. But that's like the same amount. This is the growth rate as in a percentage. It grows by the same percent.
It makes sense. When I see the word constant.
Yeah, but
I think it-
this
yeah.
this told you like it's a percentage growing by the same percent. Okay, now it's easy. It says at T equals 1 there's 100 bacteria. So what are they giving you there? A of 1 equals 100. And in T equals 4 there are 600 bacteria. A of 4 equals 600. Alright? And it says determine the number of bacteria n. Okay. So should we plug them in? So what's your first equation? 100 equals A0 e to the power of r. Is that clear? What's your second equation? 600 equals A0 e to the power of 4r. Who remembers how we solved this equation? Not an elimination.
Set them equal.
No, you can't set them equal.
Why not?
Yeah, well, you're just going to set them equal? They're not equal. They're 100 and you have a 600. You can't just naturally set them equal. Okay, the fastest way to do the problem is just divide them. But you want to divide this by this. Okay, draw an arrow like that. We're dividing that way. Because the algebra is faster. I'm going to divide. Girls writing good notes, write down divide. Because what's 600 over 100?
6.
Ah, and what's A0 over A0?
1.
That collapses. Careful, what's E4R over ER?
E3R.
E3R.
Oh yeah.
Okay, now can we get R quickly? So, R equals 1/3 ln 6. Yes? Now, can we plug it back into the first equation? I'm going to plug it back into the first equation. So I have A0 e to the power of R, which is 1/3 ln 6, equals 100. Okay. For the really advanced kids, I'm not even going to touch a calculator. For the really advanced kids, can I write it this way? ln 6 to the power of 1/3. Yes? 100. Oh my God! So what is it really in the next step? So what is this guy really in the next step? 6 to the power of 1/3. Because e to the power ln monkey is monkey. Equals 100. So what's A0? What did I do last step? Just divide. 100 over 6 over 100. And that will be the answer. You just plug them in. Of course, I want you to relax. On the test, you're using calculators, right? Using calculators. I'm just showing you how I'm solving it without touching a calculator.
And we are
Moving on to the next problem. By the way, I'm letting you know what you're doing for today's homework. You are, once again, you'll take I want to boost some of your grades. I don't want your grades to languish in a, I just made up a crazy phrase. The metaphor is not perfect, but it's still silly and funny. In a puddle of mediocrity.
That's cute.
It's kind of interesting, like a puddle of mediocrity. I just made
I
up.
laughed on the inside.
You laughed at it. It's like Mr. Borwini died a little on the inside. Okay.
He was right today.
A couple of enters, please. Couple of enters. Okay. Okay, yeah, enter now. Okay, it says students participating in a psychological experiment attended several lectures on a subject. At the end of the lecture and every month for the next year, the students were tested to see how much of the material they remembered. The rate of change of the average scores, what should we write down? ds over dt, was found to be inversely proportional. What are we writing?
1 over.
K over.
Monkey? Or
Inversely proportional to t plus 1. That's it. They just said write a differential equation. Alright?
That's
And
That's it? We are D?
No. One more. End a couple of times, please. Okay.
There was.
Oh. Okay. I'll read the problem. Oh my God, this is a multiple choice problem. I'll give you one piece of information. I was in the middle of typing when the bell rang. Okay. The question says the rate of change of the number of people infected with the virus is proportional to the product of those infected and those not infected. And the question said, if there are 200 people initially, write a differential equation. Okay, there are 200 people. So how do I write? What am I writing? D n over dt or dp over dt, n being number or p being population. Okay, let's see who's very clever. So there are 200 people in all. All right. So is proportional to. So you can write k. Okay, the product of those infected. Okay, that should be actually n. The product. Oh, okay, yeah, that's fine. The product of those infected and those not infected. What do we write down? There are 200 people in all. At any point, at any time point t, there are n people infected.
Parentheses 200 minus 1.
We're calling it n. We're calling it n. Tell me what to write. 200 minus n. That will give you the number of people not infected. Read the question. Times n. Number of people infected, number of people not infected. Times. Product.
Oh, I didn't see that part.
Product. I even underlined it. Okay. That was a lovely product.
And we are.
Okay, so guys, today you're doing the take-home test on differential equations. All right.
Oh,
I'll send you the room. Huh?
We're doing numerical sum?
Yeah, you're doing take-home test on chapter 7. Logistic functions. Some of the stuff we discussed. Okay, make sure you graded it. Put it in there, please. If you have any questions of that, please ask me. Yeah. Like I did this, you had this.
No, she yelled at me when I did that.
No, I see the error in you. This integral is completely wrong. How do you integrate 1 over r into